As we have seen before, some processes in life can be modeled as mathematical equations. I hope you know that the regulation of electricity that comes to your house has some basis on equations like the Ohm's law. Equations are a general way of referring to these wonderful realities of life. They come in different forms and serve variant purposes. Equations are relationships between expressions. These expressions are made up of terms which can also be fractions. An expression like x plus 2 all over x minus 3 is an example of an algebraic fraction. There are two peculiarities about algebraic expressions that are fractions, which we will talk about just now. First, when the numerator of an algebraic fraction is equal to 0, the expression is equal to 0. Second, when the denominator of an algebraic fraction is equal to 0, the expression is said to be undefined. In the first case, when the expression is said to be equal to 0, we can see it in this example. If we have x to be equal to minus 2 in the fraction x plus 2 all over x minus 3, the fraction becomes minus 2 plus 2 all over minus 2 minus 3. This is equal to 0 over minus 5, and this is equal to 0. To find the values of x for which an expression is equal to 0, we equate the numerator to 0 and solve for x. This is very important when finding the values of x or any independent variable for which a function will be equal to 0. If we have the function y equal to x plus 2 all over x minus 3 defining a system's operation, x in this case is the independent variable and y depends on x. Y can also be seen as the output while x is the input. So, for the values of x for which there will be no output, that is to say y is equal to 0, we equate the numerator to 0 to have x plus 2 equal to 0. Collecting like terms, we have x equal to minus 2, as we have seen before. So when x is equal to minus 2, y will be equal to 0. Hence, no output. For the second case, when an algebraic expression is said to be undefined, the value of the denominator is equal to 0. This means that the value of the fraction is not found anywhere on the graph. This is because anything divided by 0 is undefined. Division by 0 is impossible. If you look at the graph of y equal to 1 over x, you will see that as x, which is the denominator, gets closer to 0, the magnitude of y gets bigger and bigger in both negative and positive directions of the y-axis. But the curve does not touch the y-axis when x equals 0. So for our earlier function, where y is equal to x plus 2 all over x minus 3, we equate the denominator to 0 and solve for the value of x. We have x minus 3 equal to 0. Therefore, x is equal to 3. This implies that when x is equal to 3, y is undefined. Some may say y is infinity, but this is not an appropriate term to use. This can also help in knowing what value of input will bring about an uncontrollable output. Hence, the system is protected from that nature of input. What have we learned? We now know that equations can represent actual systems. Also, we know that an algebraic fraction is equal to 0 when the numerator is equal to 0. Finally, an algebraic fraction is undefined if the denominator is equal to 0. Love learning.